Well, we always are looking to be the best. The first rule is do no harm, right? So you definitely hit the nail on the head with the conservative approach of how we build our hardware. Well, we've been doing this for 50 years. We know this works. But as times have changed, our components have changed. Even in space, we're dealing with bottom terminating components. We're dealing with the column grid arrays. We're dealing with QFNs. We're dealing with all those things that are out there in the commercial world, but we're putting them on spacecraft board. So it's very challenging to clean the boards the way we always did with the changes that we're seeing in our components. And so that has been one of the things that, we were looking at. There wasn't anything wrong with the solvent cleaning, but it only took us about a quarter of the way through our process.
That's my guest, Wendy Casker from Johns Hopkins University's Applied Physics Laboratory, next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to another episode of Reliability Matters. I'm your host, Mike Conrad. Jim Collins, author of the acclaimed business book, Good to Great, Why Some Companies Make the Leap and Others Don't, published by Harper Business, a book, by the way, I highly recommend, stated, "Good is the enemy of great." How many times have we settled for good or good enough? The pursuit of great is often foiled by the fear of leaving something behind that's working well. After all, why risk the guarantee of good for the uncertainty of great? Well, sometimes we seek great because that's just who we are. Other times, we seek great because of other factors. My next guest had a customer that demanded their circuit assemblies be built with materials that were indeed good. Good had never let them down. Exterior factors would limit the ability to continue to utilize traditionally good materials, and alternate materials would soon be required. This presented an opportunity to seek great. My guest today is Wendy Casker, a manufacturing engineer with Johns Hopkins University's Applied Physics Laboratory, which is located in Laurel, Maryland. Welcome, Wendy. Thanks for joining me today.
Hi, Mike. Thank you for having me.
Oh, my pleasure. So let's start with a little bit about you. You're at Johns Hopkins Applied Physics Laboratory now. Where were you before that? What led you there?
I started my career, I have a degree in industrial engineering from University of Massachusetts, and I spent most of my career in the New England area between Massachusetts, New Hampshire, and Maine, doing manufacturing engineering work, some for OEMs, and towards the beginning of 2000, I hit the contract manufacturing world and spent about 9 years in that. And then I worked for a tooling company for a bit. I kind of was more of a product engineer than a process engineer. So I was responsible for making sure people were happy with the product that they got. And then we built it the way they wanted it. Took me all over the world, which was really fun. And 2009, the tooling company I was working for, that was during the economic downturn. So we got kind of hit by that. And so I found myself looking for a place to go. And I had visited APL, which is what I'll call work, APL for a conference, a local SMTA show back in 2008. And I thought, well, we like it down here. Let's take a look. And the day I looked, they had an opening for a manufacturing engineer. So I applied and went through the interview process and landed there in July of 2009.
Oh, very cool. So tell me a little bit about what Applied Physics Laboratory does, APL does. What type of work are you known for?
We actually, APL is a university affiliated research center, or UARC, and we're basically federally funded through different sponsor agencies in the government. So our largest contract is with the Navy. We became famous at APL due to the I think it was called the proximity fuse that they were making in World War II. And we developed GPS and the transit satellites. And since I've been at APL in the past 10 years, there's been a big move into healthcare. systems engineering of healthcare. Systems engineering is very, very important at APL. Air and missile defense, cyber security, soldier warfare, safety, and understanding like biological impacts of, an IED going off under a Humvee or something like that, and all kinds of other interesting things. But mainly we're known for Navy work and for our space work.
Definitely all high reliability.
Yes.
And what do you do there, Wendy? What's your primary responsibility?
Well, I've been a working manufacturing engineer for about 9 years, almost 10 now. And we basically have a small factory in our lab. We have an SMT line and with a pick and place and a reflow oven. And we also use vapor phase technology for reflow now more often than we use convection. We have AOI, we have X-ray, we have 2 different X-ray machines, and we have some of the best people around. So I particularly work mainly with satellite hardware. So I, over the years, have become part of the RF team as the lead manufacturing engineer building RF assemblies for the radios that go on the spacecraft that we build, and also power distribution. I also do process development. New parts come in. We have to make sure that we can actually manufacture them reliably. So we do a lot of qualification builds, process design, process development. So it's a really fun job.
Okay, I'm going to ask you a completely unscripted question here, and this is just topical. So the Chinese just landed some kind of lunar device on the backside of the moon. And yep. I remember from my childhood watching Apollo launches in school. And of course, the movie Apollo 13. And whenever the spacecraft went to the backside of the moon, the dark side of the moon, they were out of communication until they came around the other side. Is that still the case? Or I assume since the Chinese chose to land on the dark side of the moon that they found a way to communicate?
I actually wouldn't know that, but I understand that when, like, for example, New Horizons, or even Parker Solar Probe, which is the one that we're going to talk about later, I think, when they go around an object, I believe that there's some kind of radio silence, but the data is still being collected. It just can't be sent. So I believe that's still the case. I don't think they found a way to communicate through planet.
It's kind of like driving under an underpass or an overpass. When you're listening to satellite radio, everything just kind of disappears for momentarily. Yeah, line of sight.
I think that if somebody wanted to do that, APL would be the place that it would happen.
I thought I'd start there. If APL doesn't do it, nobody does it, right?
Nobody can. Yeah, we always say that. Actually, if it's hard, if it was easy, anybody could do it.
Right. So and if it's hard, APL. Yeah, that makes sense. Yeah. So, you work APL, you work with customers with, to say the least, demanding reliability specifications. And my experience in my business working with aerospace and military customers is that they're very slow to change. Reliability is so important that many extreme high reliability customers cling on to trusted materials and methods that have proven effective, even if newer materials and methods are shown to be better. So this is kind of the good is the enemy of great mentality. Some, or maybe perhaps all of your customers, or at least many of your customers, require circuit assemblies to be cleaned using traditional methods meaning solvents. They've been around forever. But a lot of the solvents are at their end of their life due to government mandated chemical phase outs and company health and safety departments regulating the use and storage of certain types of materials, as well as local air quality management agencies reducing allowable VOC emissions. With that being said, how does APL satisfy its customers while still complying with the ever-changing environmental safety and disposal regulations?
Well, we always are looking to be the best. The first rule is do no harm, right? So you definitely hit the nail on the head with the conservative approach of how we build our hardware. Well, we've been doing this for 50 years. We know this works. But as times have changed, our components have changed. Even in space, we're dealing with bottom terminated components. We're dealing with the column grid arrays, we're dealing with QFNs, we're dealing with all those things that are out there in the commercial world, but we're putting them on spacecraft board. So it's very challenging to clean the boards the way we always did with the changes that we're seeing in our components. And so that has been one of the things that, we were looking at. There wasn't anything wrong with the solvent cleaning, but it only took us about a quarter of the way through our process and in a degreasing type situation. So the rest of the way we were doing manual brush cleaning and, it's really a painful procedure because you can't control it. So
right.
We would kind of, I don't want to steal your thunder, but as I got more involved with that part of the assembly work, that's what led me to attend my first SMTA IPC cleaning and coding conference, because I was looking for something and I was trying to figure out what can I do, and I wanted to find a way forward because I had come out of industry where I did no clean. I also did water wash.
Well, that's perfect. You didn't steal my thunder. Yeah. You actually gave me a great segue. And when you mentioned your first IPC SMTA cleaning and coding conference, and for those people who aren't in electronics, that's IPC and SMTA are two of our industry trade associations. IPC writes standards. SMTA is a chapter-based organization. I think it was 6 years ago you attended your first cleaning and coding conference, which is in Chicago.
Yes.
And that seemed to produce what I would call a light bulb moment with you. Can you tell me more about that?
Well, I went to Chicago in November of 2012. And I think I told you this already before, that the day of my flight, I cut my hand at work and I ended up having to get stitches in my hand right before I got on the plane. So I basically sat in this cold auditorium where I think it was a big hotel conference room and with my hand up basically for 3 days. And I just kind of listened and I didn't know anybody. I was there by myself and I heard some really interesting presentations, and especially by this guy named Mike Conrad. He was a pretty great speaker, and I was really struck by what was going on out beyond the APL perimeter, if you will. And I thought I should probably rethink my ideas of cleaning and rethink, or maybe how can I add in another cleaning method without scaring people. And so I left that conference still not really knowing anybody, but I think I did meet a few people. But it was I left coming back. I said to my manager at the time, but we should look into this. We should do this. I think we can do this. I know I can do this, And so he told me to go get it, go figure it out and see what we could do. And so that led me to what we call a technical initiative, where I apply for some funding to go off and do a project that could benefit APL, hopefully, and report. We would report back on it every quarter of what we were doing, and so they said yes, and so that's really how my personal introduction to you happened, right? Through the opportunity to have funding to go off and do this. And because we have very progressive leadership, they were like, yeah, if you can, make it better, let's make it better. And so that's really how it happened.
Well, I'm not trying to blow smoke your direction, but it does say a lot. It does say a lot about APL's management because when an engineer comes with a light bulb moment with the next great idea, it's very common. I mean, we've all heard it, to get a response more similar to, hey, what we're doing is working. The customer's not complaining. Let's just keep doing it, because no one really wants to put their neck on the chopping block in case something doesn't work. So
right.
In an atmosphere where the customer's happy and, even though there's some, environmental and safety things going on, but no one's really screaming, to open the opportunity up to do some experiments to prove a better way to do anything is quite enlightened thinking on behalf of management, particularly something in your world.
I agree with that. And also I think to some extent disruption is promoted. So we have in the past, 7 or 8 years, they've really been kind of gearing us towards, innovating, thinking differently, design thinking, and kind of do new methods of thinking that can improve the laboratory and help us work together better and serve our sponsors better. So we do have very really inspiring programs and projects that we can work on as in teams, or we can do our own things, or, you just have to be kind of brave enough to ask for it.
I love the term disruptive thinking. That's more of a Silicon Valley kind of West Coast phrase. It's nice to hear that coming out of the other coast, in particularly in high rel, space communication type environment. So, what did you do with your discovery? So you come back from the cleaning and coding conference, all jazzed up. You talk to your boss. Your boss says, yep, start disrupting, prove it, Wendy, prove it. So what were your next steps?
When I first got the funding, I called my manufacturer's rep, and because I didn't know that many people, so he had a good line card. So I called him up and said, hey, I want to do this. Can you help me? And he was more than willing to help. He was actually really excited to help. And he connected me with with a chemistry supplier. And so we fabricate our own board. So I had enough money to build a bunch of IPC B52 test vehicles, which for people that aren't in the industry, it's basically a template that a lot of people use to test different processes. So everything is always the same. And so we fabricated those boards in our shop. We built them with some dummy parts that I purchased from a dummy part supplier. So they come in kits. So I had a little kit for each board. We subjected them to our normal process. I washed 5 of them in my degreaser and put those aside. And then I went to the chemistry supplier and I washed 5 of them in an aqueous cleaner with a chemistry that was recommended by them for the paste that I use. And it was a saponifier. So
water-based rather than solvent-based.
Water-based, yeah, soap and water, right? So
yeah, sure.
So they, I brought the boards back to APL and I sent them off to a independent laboratory which did surface insulation resistance testing and ionic chromatography, looking for contaminants or any ionic residues that are left behind. And actually, as it happens, the lab that I used was also one of the presenters at the first cleaning and coding conference that I went to. So I kind of had them in the back of my mind. And I've used them again several times since then for other things. Anyway, so that's how you make those connections as you go to these conferences. Sure. So when the results came back, I was very happy because the degreasing process was good. No one had ever asked us for the data, like, show me that your process is good per the IPC standards, right? So no, we never had that. Now I do. I have that objective evidence saying vapor degreasing is okay. The water-based cleaning process came back better, not in a grand, magnificent amount, but better. And so now I have the opportunity to add in a better process that's going to cost less, with the initial capital outlay to bring in the equipment, the training and whatnot. So that's how it happened. And then it took me, 2 or 3 years to convince our customers, internal customers, that water would not hurt their board. They were really afraid of that. They were afraid that washing in water would ruin their board. And so I had to put a lot of my own personal credibility on the line to say, hey, I'm not here to hurt your board. This is what we do. And I was fortunate enough to have someone shepherd me around to meet all these people and show them my presentation and show them my data. And, I had all this information and they really didn't know what to do with it at first. But I was fortunate enough that we had a new program coming in that was a quick project, less than a year, which is quick for us. And he said, I want you to do it on my board for our flight. And I was like, that was the door I needed to have open.
So when you say flight, you mean like space flight, right?
Space flight, right.
Wow.
So he opened the door for me. He trusted the data. He trusted the team that we have doing all this work to let us do it. And it was very, very successful. And so from there, now we've kind of cascaded our way into like all of the projects. But it took a long time. It took a lot of, patient explanation. People don't understand because they're designers. That's not their thing. We're manufacturing engineers. That's what we do. we try to find a better way, the most efficient way, the safest way, and so that's kind of where it was. But it took one engineer to say, let's do it. And then everybody else kind of fell into place after that.
Wow. So you found a fellow disruptor, not just within APL, but out at your customer. That's amazing.
I still work with him every day and he's still doing it. So yeah,
that's great. That's great.
Really great that he had so much faith in us.
That's great. So what was APL's reaction to the customer's approval of the new process? I think you alluded to it, did that open the doors to more disruptive thinking?
Well, actually what it did was we have a lot of mission assurance people that are, responsible for the end, the assurance that we are meeting all the requirements that we're supposed to meet quality wise and software wise and whatnot. And they do a lot of the vendor checks. So some of them are actually supplier quality engineers or SQEs, sort of in the real world, that's what you would call them. But when I was, talking about this with them, we have a few of them that are very manufacturing oriented and they do visit a lot of vendors. They were taking my information that I was telling them and then holding the vendors like, hey, I want to see these numbers. When did you do your SIR testing? So it was sort of put the vendors on notice that, they've got to have this data. And it was really, really fascinating actually to see that happen. And yeah.
So tell me a little bit about the testing there. And keep in mind, there's people that subscribe to this podcast that aren't necessarily in the electronic assembly industry. They're reliability engineers in other industries. So I hear SIR, that surface installation resistance tests. And what other types of testing, analytical type testing, did you perform to come to the conclusion that a result was better or no worse, or whatever the results came to?
Well, the surface insulation resistance test is done in heat and humidity. So if there's any, and it takes 106 a week, 7 solid days. I'm not really an electrical engineer, but it's cycling the chart. Can you help me with that? I don't know what that.
Yeah. So SIR, surface insulation resistance, in a simple word, is just measuring the amount of electrical resistance between 2 points under certain circumstances. So if a circuit assembly is dirty, if it has ionic or conductive contamination on it, then one would have would measure more conductivity, less resistivity between 2 points on a board. And then if you put the board into harsh environments, heat, humidity, that could be exacerbated. So we're measuring how clean a board is by how much electrical resistance is measured between 2 points. I think you also performed rose testing and adhesion testing. Yeah. Can you tell me a little bit about that?
Yeah, the rose testing was just for like a sanity check, because we are required to do the resistance of solvent extract.
Yes, that's the rose test. Resistivity of solvent extract.
You plunge the board, the assembly, into a bath of alcohol and water mix, and you turn it up, and then you're running the extracted liquid through a sensor, and it's detecting the amount of resistivity in that solution. Sure. And so we have to meet, and we have a number that we need to meet as far as and I hate this number. It's 10 micrograms metric per square inch English. I hate that number, but that's what it is. It doesn't make any sense to most people, but that's what it is. And you're basically, if you have a square inch of board surface and you have a reading of 2 micrograms per square inch, then and you're measuring that whole surface area before you plunge the unit into the bath. Then you can safely assume that you've removed any dangerous contaminants.
Anything ionic, anything conductive. Right.
And we are required to do that on every board that we can formal coat. So it's a lot out in industry. People are checking their cleaning process a couple times a day. We are doing it on every single thing that we build.
100%. Wow.
100%.
And there was also an adhesion test too that was done, right? With like a shear test.
Yep. Well, I wanted to do some compatibility checking because one of the drawbacks to the solvent cleaning is that it attacks epoxies and things like plastics and all temp. And we have to do a lot of, because we're launching, the hardest part about space work is launch. So everything we're doing is protecting the board from the vibrations of launch. So we are gluing, staking, bonding, underfilling, just anything we can do to keep the parts on the board. We're securing the hardware so they can't back out with epoxy stripes or torque stripes, if you will. So what I wanted to figure out was I knew that the solvent cleaner was not, once we started putting the epoxies and the polymer material onto our assemblies, we could not go into that unit and clean that way. So that happens fairly early in our process. So I wanted to see, just because I was curious and I had a little money left over, where I could go with these materials, like what would happen if I washed them in the aqueous cleaner with the chemistry setup that I have. So we made lab shear samples, which are basically two pieces of aluminum, and they're plated. And I don't think they're anodized, but they're plated. Sometimes we have them painted. And you basically put your epoxy. There's 5 fingers on each one. You put your epoxy on there, and each finger, and then you put it in you can put another one on top of it. So it looks like a big, like when you put your fingers together. So it's like 2 hands.
Sure.
And then you put it in a fixture and you squeeze it together, and then you cure it the way you would normally cure it. And then we take it to our material. We have materials lab right down the hall from my office, actually. And they cut them apart, and then they basically break them. And they see where the adhesion is, where the cohesion failures are. And we turned out and we also were testing durometer hardness testing, because we have to do that as well. So we have very well-known materials, and we have just a standard suite of materials that we use for all these processes. So we have all those numbers. And so when I did all this work in with the compatibility, I found out that the water was not harming our materials. So it wasn't making them worse, and it wasn't making them better. There were some differences, but sometimes we didn't have enough pressure, so we would have an adhesion failure, and that's like an operator failure. Like we didn't squeeze it together tight enough. So we found out some things about it, but it actually proved to be safe that way. So that's what that was my second conversation at the Clean Conference. So the first presentation I did was just on how we brought the process in. The second one was on the compatibility. Right.
You changed your credentials. You went 6 years ago as an attendee, and then this event is only every 2 years. So the next event, which I think was 2 years later, right? You showed up as a speaker, and
yes.
and you presented a paper. I was there. It was very impressive about changing your customer's mindset to go from, I don't think these weren't your words, but this is the way I took it, from good to great, from a good process to a better process with that met the environmental requirements of APL and the safety requirements of APL and the demanding reliability requirements of your customer, all kind of wrapped up into one process, right?
Yeah. Mm-hmm. And when I gave that presentation, when I was it was the first day, so it actually, I think, was a tutorial. And I think that the organizations really wanted to have people who are doing like real things in the real world come in and talk about what they did, rather than, no, don't take this the wrong way, a vendor coming in and talking about, right?
It's always better to have a real live breathing customer. Yeah, exactly.
Because so by the time, and you were there, and so by the time, I believe that was the day that you had a picture of a car with a whole bunch of snow on top of it. So I think that was the one. But at the end of the presentation, I had a lot of questions. I was really shocked at how many people were fascinated by this, because to me, it was just like work, So I wasn't expecting the feedback that I got. And so that day, I'll never forget this. Dave Adams from Rockwell Collins stands up and goes, "Can you help me?" And so I ended up getting involved with the cleaning and coding subcommittee and doing some work for them. So that was great, because Dave and I have been working together for the last 4 years, and I never would have had that opportunity if I hadn't gone to that conference.
Well, you seem to also have opened up the spill gates, because I remember at the last conference, which was just last November, a few months ago, there was another aerospace company, I think it was Northrop Grumman, that presented a paper similar to yours, in that they had they talked about their journey to take their customer which I don't remember. I assume it was the military, on a journey to switch from a solvent environment to an aqueous environment. And I remember thinking, oh, this is familiar. I heard this 4 years ago, and it's nice to see that other companies are doing the same thing, because environmentally superior products and products which are more safe sometimes are presumed to come with a flip side, which is, well, they're not quite as good. It's like sugar-free, low-calorie food. It doesn't taste as good as a big cheese pizza would, right? So sometimes, the low calorie in our business would be environmentally safe and or environmentally responsible and health and human safety and all that stuff. Usually when those attributes rise, the function of the results of it lower. So it's good to have a win-win. Good for the environment, a win for the environment, a win for the employees who are handling the material, a win for the end user who has a product up in space that doesn't shake to death on launch.
I was really impressed with that presentation, and I was really delighted to see someone else kind of following in my footsteps, if you will. And she's right down the road from me, and she's it's just really great to see women doing electronics manufacturing. There aren't a ton of us, but with people like myself and like her and others that are now like coming out, I think, we're kind of leading the charge. It's not just, anybody can do it. It's not
just an old boys club anymore. I
didn't want to say that, but
I'll say it. Yeah. I've been in this business for 30 plus years. I've seen it.
I've had a wonderful
The perception is our industry is gentrified and male oriented, and that's changing. We're getting younger engineers. We're getting a lot of women in engineers in this industry, and it's just I think all that whenever you broaden the spectrum, it just leads to more disruptive ideas and ideas that kind of challenge the foundation of good is good enough. And
Right. It's I will say I've had a fabulous career, and I do a lot of the tours at APL for new staff and things like that. And I'm always trying to convince somebody to come and spend the day with us, be a manufacturing engineer for a day, because once you do it, it's so much fun. You just can't leave. So it's no matter where they come from. And we always have a lot of interest in people wanting to come back and see more and talk to us about more things. So, we have to be ambassadors for our work. And I'm happy that manufacturing is making a comeback. And I'm glad that I've been able to just do like such interesting work that I can actually see that my work is flying around the sun. It's amazing. So,
well, tell me about that. Yeah, we alluded to it, but one of the projects that you've worked on since the change in methods, the new disruptive method, is now on going around the sun somewhere. Tell me about that.
Yeah,
that spacecraft.
Parker Solar Probe, and it was an idea that was germinated about 50 years ago with Dr. Parker, and he wanted to investigate the sun and the weather from the sun and what's going on over there 93 million miles away and how can it affect the Earth. And so we built this amazing spacecraft to travel around the sun. So you can imagine that there's how do you stop everything from melting, and things like that. So they developed some new materials for the heat shield. The electronics are all, on board. It's not a really big spacecraft. It's actually pretty small. And it's, all of our hardware. It was the first full spacecraft mission that everything that we built was washed in aqueous at least once. So, so that's pretty exciting. So I'm really happy about that. And
you also win the award for cool job. I come home from work. Someone says, "How was your day?" Yeah, yada, yada, yada. Someone could ask Wendy, "How was your day?" I built this rocket. Built this spaceship. It's around the sun right now.
Well, I always tell people ask what it's like to work at APL. And I said, always compare it to the movie The Martian. And when they were having a problem on Mars and all the engineers were standing around in a circle talking. And we really do that. So that is really a thing. We do a lot of talking, talking ourselves into something, talking ourselves out of something, throwing ideas around, looking at data. It really does happen. So it's really fun because it can be really collaborative sometimes.
Yeah.
So
And disruptive, as we hear. And disruptive.
Yeah, sometimes. We don't want to break anything, though. So.
Right. Disruptive in a good way.
Damage. In a good way. Yeah. So it's been a marvelous experience to work on this and to be able to do such practical work and have so many people interested in it. It's been like one of the highlights of my career.
And it's been a marvelous experience. And this conversation has been a marvelous experience. I really appreciate you being my guest on Reliability Matters. If people have questions for you, I will encourage everyone to send me emails. My information is on your screen somewhere if you're listening to this, and I'll forward them to Wendy, and maybe you guys can form a dialogue and come up with the next disruptive idea. Right. Hey, thanks again, Wendy. I really appreciate it, and I will take you up on that tour offer. Even though I'm not a potential employee, I would love to come and get a tour from the ambassador of APL.
I spent my day changing my wash tanks out today.
Well, good job.
We're getting dirty. So
yeah. Good maintenance, good reliability.
Very, very much. Appreciate
Excellent.
it.
Thank you very much, Wendy. We'll take care.
Bye-bye.
Well, that's another episode. Thanks for listening to Reliability Matters. If you liked what you hear, please be sure and give us a like. Just click on the like or heart button below. If there are any reliability-based questions you would like to have answered or specific topics discussed, let me know. I can be reached at mike@mikeconrad.com. That's Conrad with a K. Don't miss an episode. Subscribe to Reliability Matters on iTunes or follow us on Spotify. You can also listen to us on iTunes, Spotify, aqueoustech.com, PCBchat.com, Spreaker.com, GlobalSMT.net, and our newest affiliate, Ascendo Reliability, on reliability.fm, a site dedicated to all things reliability. Once again, thanks for listening. We'll be back soon with another episode of Reliability Matters. In the meantime, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.